Hey explorers, welcome back to another episode of Virtual MOSI. My name's Catherine, and I don't know about you, but summer is starting to feel really hot. So I thought today we could focus on a couple ways we can look at the signs of heat and try to figure out how we can keep things cool. I've got a lot of fun activities and demonstrations for us today, and one of the coolest ones that I get to play with is this liquid crystal display here. It's really interesting. Can you see what's happening there with the colors on the screen? What do you think those different colors mean? It's kind of like a mood ring, right? Well, qualitatively, meaning observationally, I can see that there are different colors. And luckily, I have this little temperature gun here, so I can actually measure quantitatively with numbers what kind of reading I'm getting. So when I pointed at the black, I've got a reading of about 73 degrees Fahrenheit. And when I pointed at this bluish green here, I've got a reading of about 83 degrees Fahrenheit. So what does that tell us? Well, these colors here are a much warmer temperature than these dark ones here. Now, temperature is actually another important thing we need to think about. Temperature is just a measure of how much heat energy something has. So let's start off with our first experiment, and I'm going to measure some temperature. I'm going to get some qualitative data. I've got this fun little thing here. It's kind of like an island tray. And I'm going to pour some water into it to make an island. Very nice. Okay, so I'm going to take the temperature of the land, like the sand where you would hang out at the beach, 71 degrees. And then I'm going to take the temperature of the water. It is about 70 degrees. So I'm going to write down my data because a good scientist wants to record. So I'll write water, we had 70 degrees, and then land, we had 71. Okay, so they're starting out at roughly the same temperature. Have you ever been to the beach or maybe a lake or a pool? What have you noticed about the temperature of the water versus the temperature of the sand or maybe the concrete? Has that been the same if you've gone swimming during the day versus if you go swimming in the evening or at night? Let's do a little experiment. So we'll turn on this light here. I've got a heat lamp. Whoops. There we go. Turn that one on. Turn this one off. Okay, so I'm going to let this experiment sit for a minute, and we're going to see what kind of effect happens with the heat from the lamp on the water and the land. Now let's move over to my second experiment here. I have two blocks. I qualitatively notice they're about the same size, about the same color. I can touch them and feel their temperature. Interesting. So this one on my right feels a little cool to the touch, and this one on my left feels a little warm. Let me get a quantitative measurement, kind of some numbers here. Okay, 71 degrees room temperature, and 71 degrees again. That's really weird, right? Because this one felt cold to my touch, but this one feels warm. Yet when I take the reading of the temperature, you can maybe see there, still 71 and 71. So I think we need to investigate this a little further. And luckily, I have some ice cubes. And I'm going to put an ice cube on each one of these blocks. And I want you to hypothesize, what do you predict is going to happen when I put the ice cubes on each of these blocks? Which one is going to melt faster? Is it going to be the one on the right that felt cool, or the one on the left that felt warm? Remember, they were the same temperature when I measured them with the gun. Okay, got an ice cube tray here. And then we'll put one on each. Let's see what happens. 1, 2, 3. All right. Whoops, this one's already sliding away. I'm going to put this little fence there. What do you notice? This one is melting a lot faster, right? That's so interesting, especially since this one felt cool. Well, it actually has something to do with heat transfer, or thermal transfer, if you want to call it that. Let's test it a little further. I've got this little piece of graphite here. It's basically just sheets of carbon atoms. It's kind of like what you'd find in your pencil lead. And let's see what happens when I touch it to this. I'm not going to press very hard, just let it kind of rest. And I don't know if you can see that, but it's already melting through that ice cube. And both of these things have to do with what we call heat transfer. So some materials actually transfer heat much easier than others. So the aluminum felt cool to my touch because it transfers heat very, very well. It steals the heat from my hands. Remember, heat always travels from where there's a lot of heat to where there's not a lot of heat. Because the universe likes to be in balance. It's trying to even things out. And the aluminum, this metal, has a very high heat transfer capacity, so it's transferring heat very easily. The foam, not so much. What about the graphite then? Do you think it has a good heat transfer or a very low heat transfer? Well, I can tell you as I'm doing it that I feel the cold on this graphite. It is leaching the heat from my hand into the ice cube to melt it. I bet you can think of a couple ways that we use this at the beach. How do you keep your drinks cold at the beach? Do you like to keep it in something that has a very high heat transfer capacity or something that has a very low heat transfer capacity? That's right. Things like coolers don't transfer heat very well. So that way the air and whatever you're trying to keep that temperature don't mix, don't exchange temperature. If you're trying to keep something hot, the same thing applies. You might have a bag like this, something with a very low heat transfer, so that the temperature stays the same and doesn't equalize. Okay, let's go back to our initial experiment again, because it's had a few minutes to sit, and I'll take that measurement again. So starting with the water, we have a measurement of 70 degrees again. Okay, hasn't changed very much at all. And then I'll measure the land. 70, oops, it's going up and up. 76 degrees, almost 77. I'll put down 76. Remember, we're taking these number measurements. That means it is quantitative. So far, our water has stayed the same temperature, while our land temperature has shot way up. So let's see what happens if I turn off the light now, just like at nighttime. And I'll let that sit for a few more minutes, and we'll see what happens. Now I have a third experiment for you as well, and it has to do with heat and color. So I've got two tiles here. One is white, one is black. They're made of the same material, so they should have the same heat transfer kind of capacity. They should be the same in almost every way, right? The only thing that's different qualitatively is the color. So let's turn on the light, and I want you to predict what you think is going to happen to these tiles. Are they both going to heat up at the same rate? Is one going to heat up faster or slower than the other? Let's plug in my light, and we can see. All right. Now I wanted to remind you really quickly, if you watched our light episodes, you know a little bit about color and frequencies of light already. As a quick reminder, if you have something, let's say my blue shirt, that means every color, every frequency of light is being absorbed by my shirt except for the colors that make up blue, the frequencies that make up blue. Those are being reflected back at you. It's the same for every color. If I have this pink marker, the cap is absorbing every color except the frequencies that make up pink. Those are being bounced back at your eyeballs. And remember, white and black are very special versions of this. So we know that white light is actually a combination of all the colors. So the light that's being bounced back from this tile is all the frequencies of light. Versus the black tile, that means that this tile is absorbing almost every single frequency of color. Pretty much nothing is getting reflected back to my eyeballs. What do you think that's going to mean in terms of heat? If this one is reflecting a lot of light and this one is absorbing a lot of light? Well, let's test it out quantitatively. First, my white tile here, 72 degrees. My black tile here is 74 degrees and getting hotter. I bet if I left this here even longer, you could see the difference. There you go. If you want to take a look yourself. Oops. 74, and as I get closer, oops, it kind of jumps up to 76 and 80, depending on what's being reflected back, versus this white one, much cooler, 72. So what do we know? Well, based on what we know about the science and our own readings, we can tell that the white colors are going to be cooler than the darker colors. What does this mean if you want to go to the beach? What kind of clothing might you want to wear if you're trying to stay cool? What about in the winter if you wanted to stay warm? Can you think about how this might expand on a bigger scale? Think about our cities with all their dark roads and pavement and maybe different parking lots or rooftops. How is the color of those things going to affect the temperature of our communities? I can tell you that a lot of places have started to do things like plant trees around their roads to kind of control some of that heat absorption. Maybe they've also planted rooftop gardens. A few places I've seen have even started to paint parking lots or roads lighter colors. Can you think of anything else you can do on a small scale personally, or maybe in a big kind of scale to solve a bigger problem in order to control heat the way we need it? A lot of different things to think about. Let's move back to our first experiment one more time. I've turned off the light. It's had a chance to kind of sit for a minute, and I'll measure the water again. 69.5, pretty close to its original. And then let's measure the land. Remember, it was 76 when I had the light on, and now it's back to 71. So let's take a look at my data. I don't know if it's going to be easy for you to see there, but I've got the water started at 70, the land started at 71, and then as I turn the light on, the water stayed pretty much the same, but the land shot way up. And then when I turn the light off, like at nighttime, it got a little bit cooler, pretty much the same. And then the land went back to where it originally was. What does this tell you about water versus land? Which one can kind of hold heat or store heat better? Well, the water doesn't change very much. It takes a lot of energy to change the temperature of water. It doesn't take as much energy to change the temperature of land, right? Because we are giving it the same amount of energy at every part in our experiment. What does this mean versus if you're swimming during the day, the water is going to feel cooler than the land. Versus at night, the water is going to kind of maintain its temperature a lot better than the land. So if you're out at night and the air feels really chilly, the water might be warmer if it's been heated up throughout the day. And this actually impacts weather quite a bit. If you live near water sources, it's going to have kind of an insulating effect, right? It's going to kind of help you maintain a more temperate climate, a more temperate kind of weather. It's not going to be as extreme in some cases. All right, so we've talked about a lot of cool things to do with the science of heat today. We've talked about heat capacity, we've talked about heat transfer, and we've talked about how color impacts heat absorption. So keep all these things in mind as you try to keep cool this summer, and I hope you'll join us again. Thanks for watching. Keep discovering.